In lesson 2.4, we are combining all the different translations to the sinusoids. So we should see an A, B, C, and D movement in the graph. Let's go ahead and describe our movements before we do anything with this graph. So you're always going to start with your vertical displacement. Now, depending on where you're seeing these, I will always give you vertical displacement in front, but you could see it behind the parentheses over here if you're looking at another website. Your amplitude is being multiplied in front of your sine or your cosine. Your B value, which is how you find your period, is always, so this is all, we could put a P there for period, is in front of your parentheses. If you're looking at another website, this might have already been distributed in, so you'd have to factor it out. But I always have it factored out for you. And then your phase displacement is being subtracted inside the parentheses. If you were to use A, B, C, and D, this is C, A, B, D. But you can go ahead and put vertical displacement, amplitude, period, and phase displacement if you want to remember. So let's go ahead and write those down. So I've got a vertical displacement of 3. I've got a phase displacement of positive 15. It's the opposite of what the sine is. I've got a amplitude of 1. It's invisible right here, so we're going to assume it's a 1. It's not invisible 0 because it's being multiplied. If there was a 0 there, none of that would exist because 0 would cancel it all. So it must be a 1. And then the period, to find that, you're going to have to do 360 divided by 2. So that'd be 180 degrees for the period. So let's go ahead and make a table so that we can plot some points. We're going to start with our normal theta values. So our critical points are 0, 90, 180, 270, and 360. And you want to do all multiplication before you do any addition and subtraction. So the first thing we're going to do is deal with that 2. Since this is next to the theta, we're going to put the 2 with the theta, but you always do the opposite. So since it's 2 times theta, you're going to divide everything by 2. So 0 divided by 2 is 0. 90 divided by 2 is 45. And go ahead and keep going. So when we divide by 2, we see it starts at 0 and ends at 180, which is why the period is 180 degrees. Now that we divided by 2, we're going to take those values and we're going to add 15 to all of those. So again, 15 is touching theta, so that is affecting all of your theta values. So we add 15 to all of those. Okay, so those are the theta values that we are going to have in our graph. We divided by 2 and we added 15. Now we're going to look at our cosine values. So write down your original cosine values, 1, 0, -1, 0, 1, and those come from your unit circle. We're going to start with multiplication first. So we are multiplying everything by 1. This is unnecessary when it's a 1, but I'm just going to go ahead and show it in case it's ever not a 1. You want to make sure you have that column. And then you want to add your vertical displacements. We're going to add 3 to all those. And so those are the y values you're going to graph. So now we're ready to plot those points and make the cosine graph. So if you want to know what we did here, this is always going to be your b value first, then your phase displacement, or your d value. Then you've got your cosine and your amplitude, the a, and then you have your vertical displacement, which is the c, if you want to use ABCD. So go ahead and label your x and your y axis. We've got 15 to 195. If you subtract these, that is a difference of 180 degrees, which is your period. And we have shifted right 15 units, which is your phase displacement. There are 5 critical points. There should always be 5. You see our vertical displacement was 3. That's where our sinusoidal axis is. And we had an amplitude of 1. So we go up 1 and down 1 from that sinusoidal axis. And go ahead and plot those points. So 15 was at 4. Its cosine starts at a high point, then middle, low point, middle, high point. And connect those with a smooth cosine curve. The arrows on the end. And let's go ahead and state our domain and range. Here we have a domain of negative infinity to infinity. And we have a range of 2 to 4. There are brackets on 2 and 4 because we actually touch the points 2 and 4. So a summary of what we just saw was A is your amplitude. Sorry. That's UDE. B affects your period. It is not the period itself, but it helps you find your period. So the period is 360 divided by the B. Your C is your vertical displacement. And your D is your phase displacement. And each of these affects the graph independently. So they don't change. If whatever A is, it doesn't affect B, which doesn't affect D, and so on. Frequency is a word that you might see. This is the reciprocal of the period. So let's go ahead and take the information given to us in example 2 and make an equation and a graph out of it. So same type of problem we've been doing, just given to us, and the information is given to us in a different way. So we've got the frequency is 1/12 of a cycle. We have the amplitude is 7. We have a vertical shift of -5. We have a phase displacement of -4. It's a cosine function. That should be all we need. So let's just go ahead and write that stuff down. I've got an amplitude of 7. I've got a vertical displacement, which is your C value of -5. I've got a phase displacement, which is the D value of -4. And we know its cosine. What else do we know? We know the frequency. And that is 1/12, which tells me the period will be 12, the reciprocal of 1/12. So with that information, we should be able to write an equation. The equation will be y equals your vertical displacement first, plus your amplitude, cosine. Then we need to find a b value. Let's wait for that. Parentheses theta minus your phase displacement, so minus a -4, which will make it +4. Your period does not go into the equation, but the b value does. So your b value is 360 divided by whatever your period is. So in this case, you're going to get 30. Okay, now that's our equation. Let's go ahead and make a table out of that and make a graph. So I'm going to put my normal critical points. And then we're going to go ahead and start over there where theta is and start with your 30 and then your 4. This says multiply by 30, so we're going to have to divide by 30. by 30, divide by 30, divide by 30. So we've got 0 to 12, which makes sense because our period was 12, so we're starting at 0 and ending at 12. Then you're going to go ahead and take your 4, and we're going to subtract everything by 4. Okay, we can still check our period. -4 to 8 is still 12 degrees apart. So that's a good way to check to make sure that you subtracted right. So these are the x values that we're going to have in our graph. Then I've got my cosine values, 1, 0, -1, 0, 1 from our unit circle. And then we look at what's happening to cosine. So that's these two numbers. You're going to start with your 7, and then you're going to subtract your 5. So we're going to multiply all these by 7. And then we're going to subtract 5 from all of them. So these are the y values that you're going to have in your graph. Now plot those. We've got a sinusoidal axis at -5. And we see that at -4, we're up at 2. At -1, we're on the sinusoidal axis. And then we're below, then we're on the sinusoidal, and then we're back at the top. So your cosine wave should look like this. Hopefully a little better looking than mine. So we see that it's got an amplitude of 7 because it goes up 7 units and down 7 units. We also see that it has shifted left 4 and down 5. And it has a whole period of 12 degrees. Here we're writing the equation of the line with a graph that's already given. So this can be very complicated, but just kind of look for our most important things. So let's start by finding our amplitude and our vertical displacement. So your vertical displacement is always your dotted line, so whatever that number is. Now we don't know what it is right now. Your amplitude is the distance from that dotted line to the top and to the bottom. So let's start with the amplitude and see if that helps us. From the bottom point to the top point, we have 56 and 38. So if you wanted to find your amplitude, you could find the total distance, which would be the top minus the bottom, and then take half of it, because it's the half of the total distance. So here you have minus a -38, which really means you're adding 38, which is a distance of 94 units, and then you take half of that, you get an amplitude of 47. If my amplitude's 47, so that means from here to here is 47 units, then I can take 56, the top, minus the amplitude, 47, to figure out what that dotted line is going to be. So we're going to get 9. 9 is the y value for the dotted line. Then we've got a phase displacement of +3. So when you're looking for your phase displacement, go ahead and start with the first high point. Wherever your first high point is, whatever that x value is, that's going to be your phase displacement. Then if you trace to the next high point, if you subtract those two values, that is always your period. High point to high point. 23 minus 3 gives us a period of 20 degrees. Now we're going to take all those and make an equation out of them. So here's my equation. We've got vertical displacement plus amplitude, cosine, because we started at a high point and not a middle point. 18 is the b value because you have to do 360 divided by your period. and then parentheses theta minus your phase displacement